we're beginning 4th hour today with 3434A. This first problem talks about the transformations, which you do need to know for your exam, all of the different transformations. Now there is a question about transformations, but it's not as extensive as this one was. So it's mild, but let's go over this one. If you can do this one, you can do the one that's on your test. So how would you do, where does reflection over the x-axis go? Your parent function is absolute value of x. The reflection over the x-axis goes in front, right? A horizontal compression by a factor of 1/3. Horizontal compression, horizontal, that's where you flip this and it goes inside here. So you're going to flip 1/3 and you get 3. Left 4 units. Now left, I need to leave some room here. If it's left 4 units, it's going to be +4 here, because that's the opposite. Make sure you have parentheses here. Up 5, that's outside here. And vertical stretch by 2. Vertical, this is outside here, and it's done. In this, you should be able to do all the transformations. Now, when you're doing the transformations, your parent function, you should be able to pull that out. This would be g of x is equal to x cubed. Always remember that the x value has to be pulled out. Let's talk about these transformations. What's the first thing? Take this 2, flip it. That would be a horizontal compression by 1/2. 5 units to the right. Reflection over the x-axis. Vertical stretch by 3. Well, this is first, then this, then this, then that. We've always done it this way, yeah. It does matter. Vertical stretch by 3, and then 8 down. Yes, order matters. First, second, third, fourth. These 2 things affect your x value, these 2 things affect your y. Now, there is a graph on your test, but on this test, you were asked to use your, without a calculator. Lucky for you, you can type this in your calculator. So I have no doubt in my mind that you guys will be able to do the one that's on the test with your calculator. Everyone can do this on a calculator, right? You can type that in. There's one on your test that you can type in and match it. Okay? Next one. Do you guys remember what this means? F negative x plus 3. This is a good review?
Yeah.
It means they want you to take this function right here, and what we did was we took some ordered pairs, we made a chart. To save time, I'm going to just show you here. These ordered pairs, -6, -3, -2, -3, 2, -7, 4, -5, 7, -5. These are the ordered pairs of the original function, which is that one right there. this is the direction they want us to go. They want you to multiply the x values by -1, and then add 3, shift it 3 units up. So this is what I did. I multiplied my x values by -1, and I added 3 to my y values, and created this new, so I reflected it over the x-axis, and shifted it 3 units up. What does the word odd mean? Odd is on your test. Odd, an odd function is a reflection over the origin. So you were given this graph right here. This function, actually this is not a function. It does not pass the vertical line test, but you were given this relation. We'll call it a relation, which consists of these ordered pairs. To make this, and it shouldn't say function, but you were given this relation. Cross that out. To make it an odd relation, you will change both signs. Multiply them both by -1. And you get this. This is not on your test, but what this means is multiply the y values by -1 and then subtract 4 from the y. Even, do you remember what even means? Even means it's a reflection over the y-axis. That means multiply the x values by -1. Okay, this is on your exam. These are both the same question. And these two questions, one of them, you will be asked to identify the type of symmetry an equation is. Is it y-axis symmetrical, is it x-axis symmetrical, or is it origin symmetrical? You will be given a function or a relation. And they will ask you, is it A, x-axis, is it y-axis, is it origin symmetrical, or none of them? That's the question. I'm not telling you which equation it is. So how do you test if it's x or y-axis symmetrical? What you do is you plug for y-axis symmetry, you plug x for -x. And if you can get it back to the original, it is, but this was not. And by the way, I'm going to kill 2 birds with 1 stone. Y-axis symmetry means even. It's an even function. For x-axis symmetry, you replace y for -y. And again, if you can get it back to its original, it's x-axis symmetry. We don't have a fancy name for x-axis symmetry. Origin, you replace both y for -y and x for -x. And if you can get it back to its original, it has its origin symmetry. And that has another fancy name, it's called odd. So there's 2 questions from this. You're not asked to graph one, but you will be given a relation, an equation, like one of these 2. And it'll ask you if it's one of these or if it's odd or even. So it'll be in this format or in that format. There's 2. Questions? Okay. Moving along. Okay, now we're on the next part, 3, 5, 3, 6. There's a couple of these, f of g of x, adding, subtracting, multiplying, dividing. Primarily, these ones, compositions. Do you guys remember the difference between adding, subtracting, multiplying, and dividing? So, let's review. Okay, when you're adding, simply combine them. And make sure you put your answers in standard form. When you're subtracting, make sure you distribute. This means multiply. When you're multiplying, FOIL. When you're dividing, make sure you factor and cancel. Now, these two right here, these two are the ones that I want to make sure I go over. This is on the exam, these two. And it'll be in this format right here. These two are not multiplied. These are composition. This means f of g of x. Well, I'm going to rewrite what f of x is. F of x, because it's up on top, and g of x okay, tell me how to do this problem. This is saying f of g of x. You're going to plug this one in here. Wherever you see x, you're going to plug that in. So you're going to square x squared minus 25, right? Minus 5 times x squared minus 25. Unfortunately, that's big.
Ugly.
So we have to square that. And you get x to the 4th minus 50 x squared and then plus 625 and then minus, this is 5x squared and then plus 125. Now what simplifies? I believe these two. So your answer would be 4x, x to the 4th, sorry, minus 55x squared plus 750. Questions, anyone? That is on your test.
That problem or that type of problem?
That type of problem, one of those types, the composition is on your test.
For E, that circle's the same thing, isn't it?
Yes, that exactly, yep.
Except now it's just on.
You would plug the F, this, but you would do, for this one, you would plug this into here.
Yeah.
Yep. Okay, one of these is also on your exam, but it's not as hard. These are harder than your exam question. Could you do it? Could you do these? Let's practice some. If you could do these, you can do the one that's on the exam. So let's talk about it. So number, it looks like 2. Doesn't it look like 2?
It's a 2.
I guess it is a 2. Read it. It says, what is that?
Like 1.
A 1. These are directions. What is it telling you to do? Plug 1 in X, where? In the
For
F function. So it's telling you plug 1. See, someone who hasn't had this class would look at this and say, what the heck is this? But you guys could do this, right? 1 in for X. So you would do 4 times 1, which is 4. 4 plus 1 is 5. Then what would you do? You would do 5 times 2, which is 10.
Times 3.
Not yet.
Why?
Yes, you do.
No.
And
Just
then
did
you
times
minus, and then you put -2 in the H, and then you subtract them.
I'll see the issue.
I promise you will.
Yeah, he's right, yep,
Yeah.
yep. 3, that's 30, yep. And then minus, because of these parentheses, yep. Minus, -2 goes into the H function. -2 plus 3 is 1. What's the square root of 1? 1. And then 30 minus 1 is 29. For a minute, I thought there was a, like, that was all in, so it was 3 times all that. Yep, good. So does everyone understand you just follow the order of operations?
Can you do another one just for?
Let's do this one right here.
Okay.
What would you first do?
Plug 4 into G.
4 into G. So what is a half of 4?
2.
What's 2 minus 4?
You mean 6.
2 minus,
What,
2 minus
4,
6.
so -4.
It's -4.
Bam.
What's -4 into the F function? -4 times 4 is 16.
-15.
-15. So this goes to -15, then minus, now we're gonna do this one. And like I said, your problem on your exam is easier than this. So 6 into H, 6 plus 3 is 9. What's the square root of 9? 3. Then 3 times 4 is 12. So what's my answer? There you go. Done. Got it? Easy? Okay, the number 5 is not on your test. Number 6 is on the exam. Is the relation 1 to 1? Now we're talking about inverses. Does 1 to 1 means, does it pass the horizontal line test?
No.
No. That's your 1 to 1. So this was no. 1 to 1. Does it pass the horizontal line test? No. That's an easy one. Okay, the next one. This is on your test. How, if you are given, there's 2 inverse questions. How do you find the inverse of any, whether I give you a set of ordered pairs, or if I give you an equation? Any equation, here's 5, y equals 5x minus 6. How do you do inverse? There's two equations on the exam that deal with inverse. What does inverse mean?
Switch to X and Y.
So you got y equals 5x minus 6. What do you do then?
So,
Solve for y. So what?
add 6 into 5.
And then all you have to do is on your exam, this is what they did. They called it, here it's called f of x, they'll call it g of x. So they'll write, this is what they'll write, g of x . You don't even have, remember how we did the restrictions? You don't even have to do that. Okay? No, you don't have to know the restrictions. So, how do you do inverses if I give you ordered pairs?
Plug in your value.
Switch the Y
You just
back.
switch them. That's it, right?
Yeah.
So inverses, you just switch. So if it's an equation, you switch the ordered pair, you switch the x and the y. If it's ordered pairs, you switch the points. What if it's a picture? What if it's a graph? How do you find the inverse of a graph? What do?
Swap your value.
You swap your values. Good job. Okay? We are moving right along, very swell. Guess where we're at? We are on chapter 4.
Snap.
Okay, number 1 is on your test. Polynomials. Do you remember? A lot of you guys got this one wrong.
Great.
Do you remember what an algebraic expression could have in it and what it couldn't have? What kind of things?
Expression.
Something about the variables. The variables couldn't have something. What couldn't they have? The variables could not have negative exponents. The variables could not be where?
Underline.
In a radical. The variables could not be in the denominator. So none of this. You could not have none of that. No fractional. These are no. No decimals.
They've got to be whole.
Actually, they could be decimals because you could multiply them all. I think we did have that one. We did have that one. They couldn't be in the denominator, like you couldn't have that. Now, what about this? Could you have this? Could you have that?
Yeah.
Okay, so good. The coefficients could be, they could be, you could have this, you could have that, you could have that. So for this one I tricked you, I gave you that. Yes, that's fine,
It is.
and that's fine. So yes, this was a good expression, algebraic expression. Now, as far as what the graph of a polynomial, what does a polynomial look like? It's smooth
waves.
curves. It can't have any sharp corners. It can't have any breaks, corners, jumps. Okay, no straight line. It's all curves. Remember that? All right, next one. This is on your test. Do you remember how to find the quotient and the remainder?
I do.
Remainder. How do you do this?
Okay, so you do x minus 2. So you take the opposite of that, positive 2. Draw that thing. Then you're going to put 1, 0, because you have to fill in the space for x, 2,
Mhm.
negative 3, 1, and 7.
Okay, then what?
Then you're going to bring that number 1 down.
Bring the one down.
Multiply that by 2, subtract, and then by 2.
Wait, what do you do with these two?
Did I do that?
Add.
Oh, I'm just gonna
2
add.
times 2 is 4. Then you add.
2 times, yes, 2,
Whoops. 3. Then add.
6. And the remainder
Add.
is 13.
Okay, you add. So what is the answer? What is the quotient? The quotient is the answer to this problem.
So you go down
So
one
it's
exponent
1
value,
degree less than this, so it's
x cubed
1x cubed. These are the coefficients.
2x.
1x cubed
plus 2
plus 2x
plus
squared
x
plus 1x plus 3 with a remainder of 13 over
x minus 2.
good job. Now for number 4, if I asked you what the remainder is, what you could do is plug in what? Only for this one, you could plug in, evaluate this for f of -1. So you would do 7 times -1 to the 80th power minus 3 times -1 to the 35th power minus 5. And whatever you get is your remainder. Questions? And by the way, you get 5 for that. Okay, number 5 is on your test, and you guys are awful at long division. You have one long
Wait.
division problem, yes.
Wait, okay, so you have -1 to 80, so it's gonna be a positive.
So that's gonna be a positive,
Right, so
because it's an
7.
even,
Right,
so this is
7.
7.
Then it's gonna be a
This
-1.
is a -1.
Right, and then by
-1
-3
times -3 is
plus 3.
3, that's 10. 10 minus 5 is 5.
I just argued with you about it, and I had the right
I
answer.
know, I don't know why I even argued about it.
I literally had the right thing.
I just wanna make sure it's doing.
So that's the remainder.
That's not.
That's the remainder. Okay, this next one is on your test. It's on the exam. How do you do long division? Can I do synthetic? No, you can't. You have to do long division. So you do x squared and I'm gonna say that the test question is easier than this.
Why'd you put the 0 x there? Doesn't
Yeah,
matter.
why did you put the, there's a
You
third?
really don't need it. You don't need it.
So, yeah.
You really don't need
That'll
it.
confuse me later.
Okay,
Don't-
all right, no. I just put it for a placeholder.
Wait, why'd you put the zero?
Now this I would put,
Yeah.
But there's a third, what do you?
So,
You have to cube it.
oh, sorry.
But there's, it's 2x to the third, it's in there.
Oh, there is, I'm sorry. I thought,
oh,
That's what I was trying to say.
there it is. Did you just try to erase the problem?
I thought it was
Not here.
plus 2x cubed. There's no x squared. Right? I've been reviewing all day. It's been a long day.
Been there.
All right, so how do you do long division? We want to get x to the 4th. So x squared times what is x to the 4th? So I'm going to put it above here. So I'm going to distribute x squared times x squared is x to the 4th, and x squared times -8 is, now I'm putting it under here because these are like terms. So now what am I doing with these? I'm subtracting them. So these are going to cancel. So now I have 2x cubed. Now what is this really?
8x.
It's 8x squared. Now I'm going to bring down. Now what do I want here that I'm going to get 2x cubed? Plus 2x, right? So this times these two is 2x cubed minus 16x, right? So when I subtract, goodbye, I get 8x squared, and these are going to cancel, and I have to bring down minus 17.
By 8.
And I get minus 8, right?
No, 8.
I get 8.
You get -8 when you do the thing.
This times this, 8x squared minus 64. And subtract. And when this is going to turn into a positive 64, and negative 17 plus 64 is 47. So that's your remainder. So your answer is x squared plus 2x plus 8 with a remainder of 47 over the divisor is x squared minus 8. And that is on your test. And unfortunately, a calculator is not going to help you on that one. It's not going to save you. Okay, number 6. This is a 5th degree polynomial. Can you tell me how to write this out? What are all the zeros? -3, so you've got f of x equals x plus 3. And then we've got x plus 2. And we've got x. And we've got x minus 2. Now what's wrong with this? What's wrong with this answer? Well, the degree of this has to be odd because the left and the right are doing different things. The right side's going up and the left side's going down. Something's happening at this 0. It's touching here. So the multiplicity has to be even. So I'm going to put a little 2 there, right? Right?
Yeah.
Getting even so that it bounces.
So now we have a degree of 5. 1, 2, 3, 4, 5. Number 7. Give me a 4th degree polynomial with zeros at 2 and -1, and it's telling you that it crosses at each of these zeros. So if it crosses at each of them, each 0 has to be odd. So you could have x minus 2 cubed, and then x plus 1. Or you could reverse these two. So the degrees have to add up to be 4. But if it's crossing through them, both have to be odd. If these two don't add up to be 4, then it's not a 4th degree polynomial. Okay, number 8 is not on your test, but 9 is.
Yay.
Upper and lower bound. What's the difference?
Like going on.
If you test a positive number can be an upper bound, and a negative number can be a lower bound. A positive number can't be a lower bound, and a negative number can't be an upper bound. Does that make sense? A negative number, what you do is you will use synthetic division on this. You're going to use synthetic division. 1, 2, you're going to do synthetic division. If you get a checkerboard opposite, plus and minus with a negative, then it's a lower bound. So if you're testing a negative number, and you get positive, negative, it's a lower bound. That number's too small, try something larger. If I ask you, so all we're testing is this question should say, determine if -4 is a lower bound. It should or not. -4 should be a lower bound or not. It should never be an upper bound. It's a trick question. Or it should say determine if 4 is an upper bound or not. So that's what it should be. So let's see. I'm bringing down the 1. -4 times 1 is -4. And I'm going to add, I get -2. So far, it could be -4 times -2 is 8. So far, so good. -4 times 1 is -4, and it's a no. If this were a negative number, it would have been. But it went positive, negative, positive, positive. Does everyone understand what I mean by lower bound? If it goes positive, negative, it's a lower bound. So lower bound means this. or this. Whoops.
What does upper bound mean? Does it go by the same rule? That if it's every other, then it's upper bound?
Nope. The opposite pattern, this means lower bound, upper is plus, plus,
Okay.
plus, plus, plus. You get all positives.
Sweet.
Okay? That's on your test. Now, how do you find, you will be asked to find all the rational zeros. This is on your test. This is on your test. But the good news, the
Is
rate
you
of.
can use a
You
calculator.
can use a calculator. So, I'm gonna give you a hint on how to do this one. Huge hint. This one or this one, what I would do, I would type this in your calculator. And you should, if you type right now, type that in your calculator. Now, are you going to be able to find all of your zeros? No. The question's gonna say find all real zeros. Find all real zeros. So, if I type this in my calculator,
Real or rational?
well, it's gonna say real, but I wanna do both of these. I'm gonna do them both with you. Because your ACT test, I know might be asking you one of these too. I wish I'd had like another day to review. I feel like I'm rushing. And you guys are probably thinking, get me out of here.
You're a mind reader.
I know I am. Well, that was easy.
Where's that button?
2 and 1, right? That was easy, right? Okay. All right, go to the next one. Go to the next one. Type that one in.
Oh. Yes. You smell good.
Okay, so this one is x to the 5th plus 2x minus 10x raised to the 3rd minus 1x. Whoops. Okay, so you're gonna be asked to find all real zeros. Now this is a good problem for us to look at. How many zeros, what's the maximum number of zeros? What's the degree here? 5. How many do you see here? 5. Start looking for one that you know for sure. Can you find one for sure? Negative, who said negative? Well, first of all, could you factor something out of here? An x, yeah.
0 again. See that?
Okay, so start factoring out. There you go, and there's your 0. So you found one of the 5. Then do you think you know another one? Now, when it comes to, because you know real includes those rational, those irrational ones, and at some point you have to do the quadratic formula. Well, what you could do is hit menu, analyze graph, you know, that whole process. Well, find the ones that, because on your test, it's not gonna give you, it's not, on your test, it's gonna be written as, on your test, it's gonna give you it like this. Okay, so 0, 2, and -1 are the rational zeros. But on your exam, it's written like this. So here's my hint to you. Find the ones using your calculator by hitting menu, analyze graph. In the leftover ones, write it in factored form. This is excellent information for you. So take the ones, hit menu, analyze graph, write it in factored form. You know how to do that, right? X minus 2, and x plus 1. What's left, which is that, you're going to have to use the quadratic formula to find. And that's the best I can tell you. But at least you don't have to go through this whole P over Q thing.
Oh, dramatic.
Okay? There is one of these on your test. And the answers are, a couple of the answers are like this. So I'm giving you some help. I'm giving you a huge hint that you could type it in your calculator and you can do that. Okay, moving on. You guys know that, you guys know how to state the zeros, right? So the 0 for this is 1, -2, and 3. And you also know that at this 0, it's going to touch, cross, right? Okay, that's on your test. You also have to know the what the degree of a polynomial is, checking out the maxes and the mins. How many maxes and mins are there in this problem? Yeah.
On a test, how would they do multiple choice for that? For this kind of problem where you're just like analyzing it, right?
You know, let's see. I'll tell you. It'll say something like, it'll give you like an equation like this.
Yeah.
It'll say determine the maximum number of zeros. So what's the maximum number of zeros?
6.
Like, okay, here. Let me think. No, not, I don't want to say that. How about if I give you like this? What's the maximum number of zeros? 4,
Okay.
like that.
Okay.
How about, what's the maximum number of zeros? How about describe the left and right behavior?
Okay.
Do you remember that?
Yeah.
What's the left and right behavior? Is this rising to the left, or you guys remember the left and right behavior? You gotta know that. I was just about to go over that in this, right here. Left and right, this positive and negative coefficient. You gotta know this problem, that's why I have it circled.
Okay.
So, like for this, your leading coefficient needs to be odd or even. It's rising to the right, your leading coefficient should be positive, rising to the right, falling to the left. Your degree should be, this has a, how many maximum and mins? 1, 2, 3, 4. So this should be a degree of 5. And how many inflection points should there be? 4. It's 1 degree less. You guys did good on this, so I'm not worried about that. You guys did really good on this. Okay, how good are we on time? Good. How many more minutes? Oh, good, okay, good. How about this one right here? How do you determine the domain?
You gotta back,
You gotta know this.
and you gotta see if there is any problems.
The domain, you take the denominator and you factor it. Your domain is x cannot be 6 or -2. So it's all real numbers between -infinity to -2, from -2 to 6, union 6 to infinity. Sometimes people will write all real numbers except -2 and 6. Okay? So your domain is all real numbers except 6 and -2. Now, these ones, lucky for you, you can do what? If it's asking you to graph them,
When in doubt, calculator it out.
when in doubt, calculator it out.
Or graph out, whichever one.
Now, there are going to be some questions that are gonna ask you about asymptotes. You're going to be asked for horizontal, vertical, poles. You will be asked those questions. Let's review all the asymptotes. If it's, how do you do the vertical asymptotes? The vertical asymptotes, you set the denominator equal to 0 factor. Vertical asymptotes, you set the bottom equal to 0 and you factor, you set it, so this would be x is equal to -3.
Your critical values.
If it's top heavy, there are no horizontal asymptotes. This one has no horizontal asymptotes. Okay? If it's top heavy by 1, there's a slant asymptote. How do you find a slant asymptote? You can try synthetic division or long division. This one is, you can do synthetic division on this one. If it's bottom heavy, what does bottom heavy mean?
Have a higher, just one.
If it's bottom heavy, like problem number 3, if it's bottom heavy, what's the slant or what's the horizontal asymptote? Y equals 0. This is bottom heavy.
It's a weak acid.
And yes, horizontal is a weak asymptote. I do not believe there's any parabolic asymptotes on there. I'm going to stop here.